When it comes to astronomy, there's a lot of technology that we simply can't live without anymore, from telescopes to cameras to computers. If we didn't have these things, we would be lost. The good news is that astronomy technology has come a long way in the past few decades and continues to improve every year. Today, we're going to take a look at some of the most exciting new developments in astronomy tech that are sure to change the face of astronomy forever. Whether you're an amateur astronomer or a professional, keep watching to see what's on the horizon. TESS, the Transiting Exoplanet Survey Satellite. TESS is a NASA mission that was launched in April 2018 with the goal of finding exoplanets outside our solar system using the transit method. This involves looking for the dimming of starlight when a planet passes between Earth and the star. TESS has already made some exciting discoveries, including a planet that could have liquid water on its surface and several super-Earths in the habitable zone of their stars. One of the main goals of TESS is to find planets that could potentially support life. There are a number of reasons why finding exoplanets is so exciting. First, it helps us to understand how our solar system formed and evolved. By studying planets that are similar to Earth, but orbit different stars, we can learn more about the conditions that led to the formation of our own planet. Additionally, the discovery of an Earth-like planet that could support life would obviously be a major scientific breakthrough. While we haven't found any concrete evidence of life elsewhere in the universe yet, the search continues and TESS is one of the most promising missions in this regard. James Webb Space Telescope. The James Webb Space Telescope is the most powerful space telescope ever built. It will help astronomers make groundbreaking discoveries about the universe that we could uneven dream of making with Hubble. With its advanced instruments and cutting-edge technology, Webb will revolutionize our understanding of the cosmos. The primary mirror of the telescope is made up of 18 gold-plated beryllium segments that work together to focus light from distant objects onto Webb's for scientific instruments. These instruments include a near-infrared camera, a near-infrared spectrometer, a mid-infrared instrument, and a fine guidance sensor. Together, they will allow Webb to observe a wide range of celestial objects and phenomena in unprecedented detail. One of the main goals of the James Webb Space Telescope is to look back through time and detect the first galaxies that formed in the early universe. By studying these galaxies, astronomers hope to learn more about how the universe evolved into the way we see it today. Webb will also be able to observe exoplanets in greater detail than ever before, which could lead to the discovery of signs of life elsewhere in the universe. Additionally, the telescope will be able to observe the atmospheres of planets and moons in our own solar system, such as Saturn's moon Titan, which has a thick atmosphere that is similar to that of Earth. Webb is equipped with instruments that can analyze the composition of these atmospheres, which could provide clues about the origin of life on Earth. With its state-of-the-art technology, the James Webb Space Telescope is poised to make groundbreaking discoveries about the universe. Its advanced instruments will allow astronomers to peer deeper into space and time than ever before, and who knows what wonders they'll find. Gravitational wave detectors. Gravitational wave detectors are some of the most sophisticated instruments ever created by mankind. They are used to detect gravitational waves, which are ripples in the fabric of space-time that were first predicted by Einstein over 100 years ago. Gravitational waves are emitted by some of the most extreme and violent phenomena in the universe, such as the collision of black holes or the explosion of a supernova. These detectors are typically very large in scale, often consisting of two masses suspended by springs or lasers in a vacuum chamber. When a gravitational wave passes through the detector, it causes the masses to move in opposite directions. This movement is then detected by measuring the change in distance between the two masses using lasers and mirrors. One of the most famous gravitational wave detectors is LIGO, which is located in the United States. In 2015, LIGO made the first ever detection of gravitational waves, opening up a new era in astronomy. Since then, several other gravitational wave detectors have been built around the world, including Virgo, Kagra, and LIGO India. These detectors are not only used to detect gravitational waves, but also to study them in greater detail. By triangulating the source of a gravitational wave event, astronomers can learn more about the nature of the phenomenon that created it. For example, by studying the gravitational waves emitted by colliding black holes, astronomers can learn more about the properties of these objects and how they interact with each other. Gravitational wave detectors are still in their infancy, but they have already made some incredible discoveries. In the future, they are sure to play an increasingly important role in astronomy, helping us to unlock the secrets of the universe. Exoplanet, transit photometry and spectroscopy. As I mentioned earlier, one of the most exciting areas of astronomy right now is the study of exoplanets, which are planets outside of our solar system. Astronomers have discovered thousands of exoplanets in recent years, and they are eager to learn more about them. One of the main challenges in studying exoplanets is their sheer number. There are likely billions of planets out there, and we have only discovered a small fraction of them. However, astronomers have developed some clever methods to detect and study exoplanets even from such a great distance. One of the most popular methods is called the transit method, which involves looking for the dimming of a star's light. When a planet passes in front of it, this is similar to how we measure the phases of the Moon as it orbits Earth. But instead of looking at a single star, the transit method involves observing thousands of stars in a particular region of the sky at regular intervals. When a planet makes a transit, it causes a slight dip in the star's brightness. By measuring the depth and duration of this dip, astronomers can calculate the size and orbital period of the planet. This information can then be used to estimate the mass of the planet by measuring the star's wobble caused by the gravitational pull of the planet. Another method that astronomers use to study exoplanets is called radial velocity measurements, which involves looking for the Doppler shift in the light from a star. When a planet orbits a star, it pulls on the star with its gravity, causing it to wobble. This wobble can be detected by measuring the change in the star's radial velocity, or how fast it is moving towards or away from Earth. If the star is moving towards us, the light is blue shifted. If it's moving away from us, the light is red shifted. By measuring the Doppler shift, astronomers can determine the mass of the planet. In addition to these methods, astronomers are also developing new instruments and techniques to study the atmospheres of exoplanets. By analyzing the light that passes through an exoplanet's atmosphere, astronomers can identify the chemical elements present in the atmosphere and study the weather and climate of the planet. For example, in 2022, astronomers used the Hubble Space Telescope to detect water vapor in the atmosphere of WASP-39b, an extremely hot gas giant around 700 light-years away. The discovery of water vapor was surprising because the planet is so close to its star that it should have been stripped away long ago. This suggests that there may be a more complex interaction between the planet and its star than astronomers previously thought. As technology improves, astronomers will continue to develop new and innovative ways to detect and study exoplanets. With so much to discover, the future of exoplanet research is bright. Conclusion: astronomy technology has come a long way in the past few decades, and it continues to improve every year. From the James Webb Space Telescope to gravitational wave detectors, the tools that astronomers use are becoming more sophisticated and powerful all the time. As technology advances, we can be sure that astronomers will continue to make groundbreaking discoveries about the universe that we live in. What do you think? What are some of the most exciting developments in astronomy technology? Let me know in the comments below. And don't forget to subscribe for more videos like this one. Thanks for watching.